হ্যাঁ, মানে আসলে সিচুয়েশনের বাইরে আর কোনো কোশ্চেন দিচ্ছে না।
ওই
আগে টুকটাক দিত, এখন একদম দেয় না।
হ্যাঁ, ডেফিনেশন আগে কয়েকটা দিত 8-10টা, অথবা আউটপুট, এখন ওভাবে আর দেয় না কিছু।
ঠিক আছে, আচ্ছা শাহিদ আপনি পাইছেন তো না? ওই যে আমি লিংক পাঠিয়ে দিচ্ছি কিন্তু। হ্যাঁ,
জি স্যার, পাইছি স্যার, থ্যাংক ইউ স্যার।
ওকে, ওখানে প্রায় 24টা লেকচার আছে, বোধহয় 24-25টা, অনেক বেশি ডিটেইল আছে আর কি। চ্যাট হই, চ্যাট কোথায়? শেয়ার স্ক্রিন। Okay, so next process, and this is the final process of schedule chapter, develop schedule. That means all the preparation is already done. We have got activities, we have sequenced the activities, and we have also got the duration of all the activities. Now, the final process is to accumulate everything and prepare or develop the final schedule of the project. All right. So far, the discussion we did, actually nowhere actually we discuss about the date, actual date or calendar date. All right. But in the definition of project must have a start date and end date. So that start and end date we will calculate from develop schedule process, and we'll use project calendar. There is a concept of project calendar. That means the project is following which calendar, when will be our holidays, weekends, and what will be our working hours. All right, and what are the special holidays of our country or the project is happening in that country, in which country. Based on that, your calendar should be customized or tailored. So that is known as project calendar. So if you use any software to develop project schedule, you will see that the first work or task you need to do in your scheduling tool is first you have to define the project calendar. Then on that project calendar, you need to put your activities with their duration. Then the software automatically using its internal engine, which actually use CPM, critical path method, it can calculate the project schedule. So if you use a software, so same thing, actually same concept we are using now. We have got everything now. Now we will use adding scheduling a method that is actually known as critical path method. If you see here, to some technique, critical path method will be the main tool to prepare our schedule. All right, so input, you see lot of inputs are here, and if you can go through these inputs, you will see all these inputs actually came from the earlier processes, from define activities, from sequence activities, from estimate activity duration, and also four input we have taken from resource chapter, estimate activity duration, resource. So you see activity attribute, activity list, basis of estimate, duration estimate, all we have got from earlier processes of this knowledge area. Milestone list, schedule network diagram, we have got this from sequence activities process, and this for our from resource chapter. And another new input here we are getting, that is agreements. That means if you have some agreement with your vendors, with your suppliers, so you have to include their schedule also with your total project schedule, because they are also integral part of the project. So their schedule you have to consider, you have to include in your project. Otherwise, you will not get the exact schedule of your project, because their schedule also will impact on your project. So that's why we are taking the schedule part of the agreements that you did for this project with your different vendors or suppliers. So what are the tools we will use? We'll use, first tool we will use schedule network analysis. That means the rule of thumb we have already seen in the earlier processes, and also how to make network diagram we have seen. So with that network diagram, you have to analyze and you have to use critical path method. I will show you how to use critical path method and how to calculate critical path method to find out the project schedule. And after that, we will use other tools like resource optimization, then data analysis. That is actually advanced type of scheduling where you can use simulation that we'll discuss, and leads and lags that we discuss and learn in the sequence activities process. So that and leads and lag you can again apply here to finalize your project schedule. And schedule compression, I will discuss in detail schedule compression, how you will compress or squeeze your schedule. Because for example, after calculating everything, you get that 2 years of time you will need to finish the project. But the sponsors want to finish the project within 1.5 years. So now, how do you compress your schedule? So there are two techniques. Using those, you can compress your schedule and make the schedule to 1.5 years. So that technique we will learn here. And if you have a project management information system or any software like Primavera or Microsoft Project or any other tool that you can use. And lastly, this is very important. At the beginning of this knowledge area, I told you that Agile follow defined way to estimate their schedule. So that Agile release planning, scheduling will learn from this tool. And there is a very interesting figure here when we will discuss this tool. So from there, you can easily understand in the Agile arena, how actually we get or calculate project schedule. Okay, so let me go to these tools and techniques in detail. And then we will talk about the outputs. So I am skipping this slide. I will come back to this slide afterward. So say we have drawn a network diagram using PDM method, and we have got this diagram. All right. It is used using PDM. We have got this diagram. Now we have to find out the critical path of this network diagram. All right. So how do we calculate critical path of network diagram? Please remember in the exam, you will get 1-2 questions to calculate critical path of your network diagram. That they can, in the exam, you can get this type of network diagram drawn in the question, or sometimes they will actually using verbose or using descriptively, they can actually describe the network diagram. Then actually from that description, you have to draw this network diagram. And then you have to solve the network diagram to find out the critical path. So if the network diagram is like this, how do we calculate critical path? So first thing we have to do is we have to find out how many paths are here. That is known as network path. How many network paths are here? So here we are seeing this is one path, and that is another path. This is third path, and this is the last path. So there are 4 paths, right? Okay. So now for each path, what you need to do, let me write in text. You have to write down the path. So first path is A, B, right? C, G, right? So I am talking about this path, A, B, C, G. All right. Then the next path is A, B, F, G. All right. And then third path is D, E, F, G. And the last path is D, H, I. সবার জন্য এটা ওকে আছে? ঠিক আছে এটা? বুঝতে পারছিস চারটা পার্ট? Okay, all right. So now we will use the duration of all activities. So A is 4, right? 4 days. B is 3 days. C is 1 day, and G is 2 days. So how much? How many days total? 10 days. All right. Now calculate this path division A, B, F, G. So 4 plus 3 plus FG 6 plus 2. So 15 days, right? And for this path, DEFG 5 plus DE 4 plus 6 plus 2. 6 plus 2. So it is actually 17, right? And the last one is 5, 4, 2. That means 9, 11 days. So from this, can you say which one the which path is the longest path? Which path? So this is the longest path, right? 17 days. So this is the longest path, and right, and this is known as the critical path. So if you are asked to calculate the to identify the critical path, then the answer will be DEFG is the critical path. And if you asked to find out the duration of critical path, then it is 17 days. So that means this is the critical path, DEFG, and this is the longest path. So longest path in the network diagram is known as critical path. Okay. So if you see in the next slide, you will get the answer here. Okay, so this is the critical path. And another important thing is to understand the float. What is the float of each activity in your project? So please remember, if this, for this project, all these are the activities. All activities are inclusive, all these activities. So প্রজেক্টে যদি আপনার এই সবগুলোই অ্যাক্টিভিটি থাকে, এর বাইরে কোনো অ্যাক্টিভিটি না থাকে, তাহলে প্রজেক্টটা শেষ করতে কত সময় লাগবে? কেউ বলতে পারবেন যে প্রজেক্টটা নিয়ে আমরা ক্যালকুলেট করতেছি ক্রিটিক্যাল পাথ, সেটার এই কয়েকটাই টাস্ক, এবং আমি সবগুলো হিসাব করে বের করছি ক্রিটিক্যাল পাথ 17 ডেজ। সো প্রজেক্ট শেষ করতে কত সময় লাগবে?
10 দিন স্যার।
17
critical path, actually, that's we are calculating critical path. Why? Because critical path actually is the project duration. All right, so 17 days, we have to have 17 days to complete the project. So that's why actually you're calculating critical path to find out the project schedule. So critical path is the longest path, and that actually meaning that is the time, minimum time the project will take to finish the all activities of the project. So this is the project duration, total duration. So critical path equal to project duration. So then another concept we need to understand, that is actually float, or also known as slack. What is that? If you see the critical path, if we delay one task in this critical path DEFG, if we delay one task by 1 day, then what will happen? Can we finish the project within 17 days? No, it will be 18 days. That means we are exceeding the finish date of the project. So in the critical path, all the activities are known as critical tasks. The tasks that resides on critical path, that are known as critical path. And critical path is not having any float or slack. What does it slack means? Slack means if we delay So if we delay one task by certain amount of time, and if does not have any impact on the project finish date, then that time for that activity is actually float. তার মানে কোন একটা অ্যাক্টিভিটি যদি আমরা সময় বেশি নেই, 5 দিনের জায়গায় 6 দিন নিলাম, 7 দিন নিলাম, সেই 2 দিন যে এক্সট্রা নিলাম সেটা যদি আমার প্রজেক্ট ফিনিশ ডেটে কোনো ইম্প্যাক্ট না ফেলে, তাহলে সেই 2 দিন হচ্ছে এই টাস্কটার জন্য ফ্লোট কিংবা স্ল্যাক। দ্যাট মিন্স আমরা ওই কাজটা যদি 2 দিন ডিলেও করি, তাও আমাদের প্রজেক্ট ফিনিশ ডেট ইজ নট চেঞ্জিং। সো সেটাকে বলা হয় ফ্লোট অথবা স্ল্যাক। Okay. So float can be actually 4 types. Float can be 4 types. If you see the definition here, one is free float, another is total float, and another one is project float, and last one is negative float. So what is total float? If we calculate here, let me calculate from here. How do you calculate float for, say, activity C? So the longest path is 17. Next longest path is which one? This one, right? So if I deduct 15 from 17, then what we are getting? 2 days. That means in this path, for some activities, 2 days slack is there or float is there. That means if you delay some tasks of this path by 2 days, it will not actually has any impact on the project end date. So you see here actually float is 0 because this is critical path. All float is 0. But ABFG, so F and G is already in the critical path, so there will be no float. But these 2 days you can use for A or can B. It will not have any impact on the project finish date. All right. Then next, find out which one the next longest path is which one. So 11 is the next longest path. So if I deduct 11 from 17, I am getting 6 days. That means in this path, some activities may have 6 days of float. So which one? So I am talking about this path, right? So D is already in critical path, so we cannot put any slack here. So for H or I, we may have 6 days of float or slack. If we delay H or I by 6 days, it will not hamper or not exceed our project finish date. All right. Now, the last part is 10 days in duration. So if we deduct 10 days from 17, we are getting 7 days. That means in this part, A, B, C, G, in some activities, you may have float. All right. So for G, we cannot put any float because already it is in critical path and its float is 0. And A and B is already calculated. The float is already floated. So we will not put any float here because it is already decided that the float is 2. So only C is here, and these 7 days we can use as a float here. So the C activities float is 7 days. That means আমরা যদি 7 দিনও C টাস্কে ওয়েট করাই, তাও আসলে আমাদের প্রজেক্ট এন্ড ডেটে কোনো ইম্প্যাক্ট করবে না। So this way you can calculate the float, and this float is known as total float. Total float, because it is actually talking about the total float in the network path of that path. All right. And there are other kinds of float here. So I have just mentioned about total float, and another type of float is known as free float. So what is free float? So free float is, for example, 2 activities A and B. All right, A and B. Say A will take 3 days to complete and B will take 5 days to complete. And another task is here, C, that will start when A and B both will be finished. All right. So for example, we have started both tasks A and B at the same date. So what will happen after 3 days, A will be finished. But can we start C? Can we start C? No. Why not? Because B is not still finished. To start this activity C, both of these activities must be finished because the relationship is showing that. That means though we have finished this task activity within 3 days, but still we have to wait for another 2 days because B is not finished. It will take 5 days. So this, for activity A, there is a float of 2 days. All right. So this float is known as free float. So what is free float? That is, an activity can be delayed without delaying the early start of any successor activity. So if I delay this activity by 2 days, it will not actually hamper the early start date of its successor activity C. So this is known as free float. আচ্ছা, দুইটার মধ্যে কি পার্থক্য বুঝতে পারছি আমরা? টোটাল ফ্লোট এবং ফ্রি ফ্লোট।
যেভাবে এটাকে আর্লি স্টার্টের সাথে 2 দিন অ্যাড করব নাকি? বলেন। আর্লি এই 2 ডেজ যেটা পাবে,
হ্যাঁ, মানে সাকসেসর অ্যাক্টিভিটির সাথে ইনভলভ।
আচ্ছা, মানে আর্লি স্টার্টের সাথে 2 ডেজ।
হ্যাঁ, আর্লি স্টার্ট এন্ড successor activity, immediate successor activity. All right, it is not talking about the whole network path. It is only talking about the successor, immediate successor activity. So আমরা যদি A কে আরো 2 দিন ডিলেও করে তাও কিন্তু C এর কোনো সমস্যা হচ্ছে না, কারণ C শুরু হতে পারবে 5 দিন পরে। সো আমি যদি 2 দিন পরেও শুরু করি A কে, কোনো সমস্যা নাই, কারণ এখনো আরো 3 দিন সময় আছে যার মধ্যে A ফিনিশ হবে এবং আমরা C শুরু করতে পারবো। সো এটাকে বলা হচ্ছে ফ্রি ফ্লোট। ইমিডিয়েট সাকসেসর অ্যাক্টিভিটির স্টার্টে যদি কোনো হ্যাম্পার না হয়, আগের প্রিডেসেসর অ্যাক্টিভিটিকে ডিলে করার কারণে যে কয়দিন ডিলে করতে পারবো সেটা হচ্ছে ফ্রি ফ্লোট। আর টোটাল ফ্লোট হচ্ছে টোটাল নেটওয়ার্ক ডায়াগ্রামে, যেটা প্রজেক্ট শিডিউলকে, প্রজেক্ট ফিনিশ ডেটকে ইম্প্যাক্ট ফেলবে। অলরাইট, সো দিস ওয়ান ইজ টকিং অ্যাবাউট দ্য প্রজেক্ট ফিনিশ ডেট and this one is actually talking about immediate successor activity. So this is the difference actually.
তো টোটাল ফ্লোটটা কি আপনি দেখিয়েছেন এর আগেরটাতে?
আমরা এতক্ষণ যেটা কথা বললাম এটা তো পুরোটাই টোটাল ফ্লোট। দিস আর টোটাল ফ্লোট
আগে যেটা ছিল।
হ্যাঁ হ্যাঁ জি, টোটাল নোটের পাথ নিয়ে আমরা বলতেছিলাম। আর এটা
টোটাল
জাস্ট
ফ্লোট
ইমিডিয়েট সাকসেসর এবং প্রিভিয়াস অ্যাক্টিভিটি।
জি।
আচ্ছা, another one is project float. So what is project float? Say for example, আপনার কাস্টমার আপনাকে বলছে যে প্রজেক্টটা ফিনিশ করতে হবে 31 ডিসেম্বরের মধ্যে 2020, বাট আমরা ক্যালকুলেট করে দেখলাম, আমরা হিসাব নিকাশ করে দেখলাম প্রজেক্টটি যে আমরা এটা আসলে 5th of ডিসেম্বরের মধ্যে ফিনিশ করতে পারবো। রাইট, 5th of ডিসেম্বরের মধ্যে আমরা ফিনিশ করতে পারবো প্রজেক্টটা। কাস্টমার বলছে 31 তারিখের মধ্যে দিলেই হবে, কিন্তু আমরা দেখতেছি যে 5 তারিখের মধ্যে আমরা প্রজেক্টটা শেষ করতে পারবো। তার মানে কি, we have another 26 days in our hand। এর মধ্যে যদি আমার শেষ করতে নাও পারি কোনো সমস্যা নাই, কারণ কাস্টমার 31 তারিখে এটা রিসিভ করবে। সো এই 26 ডেজকে বলা হচ্ছে প্রজেক্ট ফ্লোট। টোটাল প্রজেক্ট ক্যান বি delayed by 26 days because customer has asked for the delivery on 31st of December. All right, so it is actually project float. So in the exam you can get question for free float, for total float, even for calculating the project float. So you have to understand the concept. Okay. So last one is negative float. Negative float means there is issue, that there is problem, there is bug in your schedule. All right. How that bug or defect can happen? For example, task A and task B. So you have planned that the task will take 5 days, and after 5 days, you can set a finish to start relationship. You can start task B, which will take another, say, 5 days. All right. So when you're executing the project, say already 10 days, you plan to start is 1st of December, and you plan that it will finish on 5th December. That means you can start this task on 6th December and finish this task on 10th December. Right. So if it happens when you execute a project that already it is 10th December, but you have not able to start task A yet. All right. So what happens? 10th December, we have to start this task, but the predecessor activity is not started yet. So in this type of scenario, what happens? Negative float happens. If you use any project software, scheduling software, you will see the float will show negative because already it is 10th December, but the earlier but predecessor activity you have not yet able to start. So from there, actually, problem or defect created in the schedule. So that is known as negative float. So if you find any negative float in your project, immediately you have to focus on that task and you have to solve that problem, and you have to solve the correct the network diagram for the future task. Otherwise, it will associate problem with other activities also. All right. So this is about floats, and there is another way of calculating critical path, and this is the actual or real way of calculating critical path. So far I discussed with you, that is actually the short way of calculating critical path. This way you can also get the correct answer of critical path. But if you want to get float, identify the total float of each activity, then this technique will give you the perfect answer. All right, to calculate the float and critical path. And this is actually mostly used in all the softwares and in the industry. So you have to understand how to calculate critical path using this method. And the name of this method is forward pass, backward pass. So who are from engineering background, they may have studied this in your graduation level project management course. So there you might have actually gone through this forward pass and backward pass method. So I am not showing this today because it will take 15 to 20 minutes to explain. So I will talk about this in the next class. Okay. So all this actually related to forward pass and backward pass that we'll discuss in next class. Okay, so I think today it is 9:40 almost. So we can stop here. And in the next class, we will finish the schedule chapter and also we'll start the cost chapter. And cost chapter is not that big, very small chapter. I hope in the next class we can finish the rest of the part of schedule chapter and also finish the cost chapter. So if you have any questions, you can ask me. Otherwise, I am actually stopping the class for today. And in the next class, we will start with the forward pass and backward pass.